at 2019 open response question number 14, turning tiles. And we're told Ryder lays out identical square tiles. You might want to take out some square tiles to help you visualize what's happening with this pattern before you go any further. Or you might just want to look at the visual to do that visualization. You can use square tiles in class and you can use them on the EQAO as well. So I'm going to visualize what I see happening here. I notice that in diagram 1, I have 1, 2, 3, 4 sides that are each 6 centimeters. So 6, 12, 18, 24 in total. I notice in diagram 2, I still have those 4 sides, but it's like one side's sort of been pushed out a little bit. We've got a side in here that's not part of the perimeter anymore, and we have 2 new sides that are now part of the perimeter. So we've added 6, 12 more to the perimeter. When we look at the next diagram, we still have these original ones. We've got these 2 from diagram 2. The end has been pushed out here, and we see that we've got 2 extra sides again. So we've added 2 more sides that are each 6 centimeters, or added 12 more centimeters. That's one way to visualize it. You might have seen it like this. You might have thought, you know, I noticed that I had 4 edges of each 6 centimeters, and I noticed that here I lost one side, but I gained 3 new sides. Well, losing 1 and gaining 3 is the same as gaining 2 new sides. Let's see if that holds true. I've still got this, I've still got this, but this time I've lost this side as part of the perimeter, and I've gained these 3 sides. So again, I've gained 3 and lost 1, so it's like I've added 2 more sides each of 6 centimeters. So before I've even started the problem, I thought about how that was growing. Now let's read what the question wants us to do. We want to complete the table of values using his pattern, but we've done some thinking about that, so we can do that. Let's have a look. In diagram number 1, we've got a perimeter of 6, 12, 18, 24 centimeters. In diagram number 2, we have 6, 12, 18, 24, nope, yep, 30, 36. Oh, that's correct. In diagram 3, we've got 6, 12, 18, 24, 30, 36, 42, 48. We don't have number 4, number 5, so we can do a few things. We can use what we're noticing happening here. And before we talked about noticing that 2 extra sides of 6 centimeters each were being added from diagram 1 to diagram 2 and from 2 to 3. Let's see if that's true in our table of values. Well, from 24 to 36, we've added 12 centimeters. From 36 to 48, we've added 12 centimeters. So we can predict that going to the next one, we're also going to add 12 centimeters of perimeter, and that's going to give us a perimeter of 60. And then we can verify that. We can take a minute either to get the tiles out or to draw it. So let's see, what would diagram 4 look like? Well, I've got the first tile. I've added the second tile. Now I'm at diagram 2. Add the third tile, diagram 3. Add the fourth tile, diagram 4. And I'm going to add up all my 6s. So 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, which is exactly what I expected to get. So we trust our pattern now, so we can say we know that we're going to add 12 more when we get to step 5, and that's 72. Now the question is asking us, is the relationship linear or non-linear? That relationship between perimeter and the diagram number. We notice that we are increasing that perimeter by 12 each time, which tells us that this change, this rate of change from one to the next is constant. It stays the same. And we know that's the definition of a linear relationship.